the major tool that we employ to analyze oligopolistic market is game theory. And here, this is a famous example of game theory, which is prisoner's dilemma. So the story is told this way. Here. There are two prisoners under interrogation. And they are interrogated separately. Now, each prisoner is blindfolded of the other prisoner's behavior, and they are making their decision on whether to confess or not simultaneously. So, if none of them confess, say we don't have enough example, or we don't have enough evidence to punish them harshly, then each of the prisoner will only receive 2 years of jail sentences. If both of them confesses, it's kind of bad, but they demonstrated a good attitude, collaborative to the jurisdiction and execution. Then each of them receives 5-year sentence. But if one confesses, the other doesn't, the one that confesses, which is more collaborative, receives a reduction of penalty. That's only 1 year of jail time. But the other one who left non-collaborative or by not confessing will receive a 10-year penalty. So this is how the story is told. And as you're looking at my cursor, this is how we tell how the game is intuitively by looking at these numbers from this payoff matrix. So look at this payoff matrix. The player, which are two player, prisoner A and prisoner B. Okay, the first player, which is prisoner A, their payoff is the leading number in each cell of the table of the matrix. So here, for instance, if both prisoners confess, then prisoner A will receive a 5-year penalty. And the second number is the payoff of prisoner B. In this case, another 5-year penalty will be imposed on prisoner B for plain confessing when player A confesses. Okay, so the leading number is the payoff of the first player. The subsequent number is the payoff of the second player, the player in the vertical column. Okay, so if we are looking merely into those numbers, what is the best outcome that they can possibly obtain? That is -2 -2. If you calculate the total years that these two players have to spend in prison combined, right? In the bottom right corner, the total years is 4, and in those cross corners, one confesses, the other doesn't confess. The total punishment is 11 years for these two prisoners combined. And when they both confess, it's 10 years. So here, if we only look at the aggregate numbers, not confessing is the best. And when will that happen? It's more likely that both will choose not to confess if they could collaborate. If, say, before getting arrested, they had a treaty, they had a swear, like the Three Musketeers, one for all, all for one. In no circumstances shall we betray one another. If that's the case, if their behaviors are bounded by such square, then possibly -2 will happen. So we call the -2 in the case where both prisoner choose not to betray the other. We call this as the collaborative outcome. Okay, but if if each of them is blindfolded, they have no idea what the other prisoner is gonna do, and there is a threat. If you choose not to betray, but if you are betrayed by the other, you're gonna receive a much harsher punishment, which is 10 years in jail. Then what will be the result? That's a non-collaborative game that we are looking into. That is a game in which negotiation and enforcement of binding contracts or collaborations are not possible. And in that case, each player is only thinking about how to make their own life better. Okay, so here there are several more concepts, elements that we need to discern in regard to a game. One is how many players are in the game. Here there are 2, prisoner A and prisoner B. And what are the strategy each player that is available to each player in the game and the corresponding payoff. So here the strategies are confess and not confess. And the confess actually means betray, right? You rat out the other one. And then we have to look into each player's best response to the opponent's strategy. And we are using an underscoring method. Okay, so let's look at the best response. So for prisoner A, if prisoner B choose to confess, if your fellow betrays you, then what is your best counter strategy? Well, if you get betrayed, if the other prisoner confesses, right? Now you are choosing between confess, whose outcome is 5 years, and not confess, and you stay as the douchebag, in which case 10 years. Then, if you are thinking about your own benefit, we need to avoid being the dolt by playing betrayal as well, by confessing as well. So it's -5 is your best strategy, best response to the other player playing confess. Now, if prisoner B choose not to confess, then for prisoner A, if you confess, you get 1 year punishment. If you don't confess, you get 2 years punishment. Still, for you, 1 year is better than 2 years in jail. Then you will choose to confess. Okay, so here, this is how we analyze the best response to all possible strategy of your opponents. And then the question moves to whether this player has a dominant strategy, which is defined as one strategy that makes the player always better off, namely remains the best response regardless of the opponent's strategy. And here we do have a best dominant strategy for A, right? Confess dominates all the rest of strategies for A, right? So no matter prisoner B choose to confess or choose not to confess, you will always find confession is the best response regardless what prisoner B chooses. Then confession, it dominates of all possible strategies of prisoner A. So confession is the dominant strategy for prisoner A. And now let's move on to B's story. Right? Then the question is, what's the best responses of B? If prisoner A chooses to confess, then B chooses to confess and then receive 5 years penalty, and not confess receives 10 years penalty. B should choose to confess. Right? You're now, as prisoner B, you're now comparing between these two payoffs of the subsequent numbers in each cell in the same row. It's -5 compared to -10. And if A chooses not to confess, B will choose to confess and receive 1 year penalty, and not confess receive 2 years penalty. Still, prisoner B should choose confess. And here, no matter what prisoner A chooses, prisoner B should choose to confess. So confession is also a dominant strategy for prisoner B. And when both players have a dominant strategy, we have a definite equilibrium of this market, which is Nash equilibrium. That's what? That is here. Okay, -5, -5, namely confession of prisoner A, confession of prisoner B. Okay, so is that the best outcome? As we previously discussed, -2, -2 is the best, not confess. Nobody betrays the other, that's the best. But here, because everybody is blindfolded, you don't know, you can't collaborate with the other player, and it's a non-cooperative setting. Under that setting, each player has to choose whatever does best to themselves. And here we fall into the pit, or namely the dilemma of a second best or inferior outcome. Inferior to the first best, which is non-confess for both, which is under the cooperative setting. Okay, so this is how prisoner's dilemma is defined. That is, in which two prisoners must decide separately whether to confess to a crime or not, and if confesses, they will receive a lighter sentence, and the accomplice will receive a heavier one. But if neither confesses, sentence will be lighter than if both confesses. That's the setting. And here the dilemma is that each prisoner, when only considering the best possible strategy that they can make to make themselves better off, the joint outcome will not be the best. The total outcome, namely the joint outcome, is 10 years, is not the best as the cooperative outcome, which is 4 years. Okay, so here there are two principles. If you have a dominant strategy, you will definitely play it. And if you know that your opponent has a dominant strategy, then you know that your opponent is gonna definitely do that, no matter what, because that's their best response, regardless how your strategy is. And now, if you don't have a dominant strategy, look at the game from your rival's perspective. If your rival has a dominant strategy, anticipate that he or she will play it. And here, as you can see, in this prisoner's dilemma, or in this game theory, in this oligopoly setting, we should always be looking over our shoulders and at least speculating what our rivals are gonna do, and then make our best response, make our best choices correspondingly. And here, this is how the prisoner's dilemma is applied to help analyze cartel and see if this cartel is a solid collision or not. So, firm A can choose to charge lower or charge higher. Firm 2 can choose to charge lower and charge higher. And as they are both charging lower, that means they are charging, say, the competitive price, right? They are competing each other with lower pricing. That's why they are charging lower. And if they both charge higher, then possibly that's because they form up a collaboration entity, right? And they decide, oh, we both sell less, so that the market is in a certain level of scarcity for our product. so we can sell our products with a higher price, with a monopolistic price, if you will. So under that setting, cartel is more like 16-16. Namely, each firm is able to charge a higher price. By how? Arguably, presumably, cutting short their products, their supplies. Is there any temptation? The answer is yes. By how? So here, at the moment, when the cartel is in fact, in its effect, then possibly the market price is 6, high. And at that moment, you are tempted to sell more price because now the price is high, right? And then sell more, you can make more profit, right? So, but at that time, the other firm who choose to still produce less will receive, will forgo, will let go a lot of profiting opportunity, will make less profit. So here it is similar to the prisoner's dilemma. It's as if you are loyal to the contract, but the other firm betrays you. In that case, this firm that stays loyal will be worse off, will be harmed, right? So the one that betrays by producing more so as to charge low so as to sell more, right? Now is able to make more profit, 20. Okay, so now let's take a look. What's the possible outcome? So if you first, what is the highest joint outcome? The joint outcome for both to produce and charge in a competitive manner, that's 24. For one charge less, one charge higher, that's 22. But for both to charge higher by producing less, that's 32. So the first best joint outcome is both firms charge higher. Is that obtainable in a non-cooperative setting? The answer is not. If firm 1 charges 4, what's firm 2's best response? Charge 4, get 12. Charge 6, gets 4. So that's to charge 12. If firm 1 charges 6, what's firm 2's best response? Charge 4 gets 20. Charge 6 gets 16. Then should also charge 4. So here, charging 4 is a dominant strategy for firm 2. Now look at firm 1. So if firm 2 charges 4, firm 1 chooses between charge 4 and gets 12, and charge 2 and gets so as to get 4. So the firm 1 should charge 4. If firm 2 charges 6, firm 1 chooses between 20 by charging 4, 16 by charging 6. So still firm 2 should charge 4. And firm 1 should charge 4. So firm 1 charging 4 is a dominant strategy for firm 1. So here we have dominant strategy for firm 1 as charging 4, dominant strategy for firm 2 as charging 4 as well. The Nash equilibrium is both firms will charge 4 and the market will be a competitive manner. And the cartel shall collapse.